Hello and welcome to your video about chemical and physical changes to matter. Really quickly, let's just remind ourselves about what matter is. Matter is anything that has mass or takes up space. So it's not energy, but it is anything that has mass and takes up space. It is going to be helpful to use a particular word here called substance. A substance is a particular kind of matter with uniform properties. Another way to think about a substance is just one kind of stuff. When we're talking about kinds of matter, there are pure substances and there are mixtures. Pure substances can either be elements or compounds. If a pure substance is an element, it's made up of just one type of atom. So it can be more than one atom stuck together, as you see in the blue and the orange examples, but notice that they're both the same kind of atom, if my little dots are representing atoms. So this blue element here, that could be oxygen. Oxygen is two oxygen atoms stuck together. Or it could be a single atom, like this gold colored one here, which could be gold. Gold is just one gold atom floating around. Pure substances could also be compounds. A compound is a pure substance, but the molecules that make it up are made up of more than one kind of atom. So in this orange and blue example, we have one blue atom and two orange atoms that are chemically bonded together. They're stuck together, and they make up a compound. So this compound might be water, which is two hydrogens and one oxygen. And then we can see that matter might also be present in a mixture of pure substances. So in this example, we have our water molecules mixed in with little gold atoms, and that would be a mixture of water and gold. Notice that they are not stuck together like the atoms are in a compound. So in a mixture, they're kind of physically mixed together, but in a compound, they're chemically stuck together. Sometimes matter changes. We've seen examples of the two kinds of changes to matter, both chemical and physical. We're going to talk in more detail about the difference between the two. In a physical change, the change that happens is just a change in appearance. So the same atoms and molecules are present, they stay the same, but they might change location. This also might be a change from pure substances to a mixture. So if I have sand and I have water separately and I mix them together, that's a physical change. I'm just mixing two pure substances together to make a mixture. Tearing paper in half is an example of a physical change. It's still made of the exact same substances, but now they are in different locations. Crushing a can, same thing. That can is still made of all the same substances. It's just being squished. It's a change in shape. And phase changes, so going from a solid to a liquid to a gas, those are still physical changes. So if we think about that ice cube, it's made of water. As it melts, it's still made of water, even when it's liquid. And then if we heat it up even more and turn it into water vapor, it's still made of the same kinds of atoms or the same kinds of molecules, water molecules. They're just in a different location, in a different appearance. They're spread out. So in a physical change, the molecules are the same at the beginning and the end. And here is a molecular model of that phase change, ice melting into water and then water evaporating into water vapor. We can see that all of the molecules present in the ice example, they are one red atom stuck to two kind of grayish atoms. As they melt, they get warm, they turn into water. The kind of molecules are exactly the same. They get even warmer, turn into water vapor. The kind of atoms the molecules are exactly the same. They're just more spread out. So this is a physical change because we still have H2O at the beginning and the end of every part of this change. This can be a helpful hint in trying to decide if the change that you saw was chemical or physical. Physical changes can sometimes be easily reversible. That is sometimes a helpful thing to think about. So for example, if I took my ice cube and I melted it into water, all I have to do to get it back into ice is put it in a freezer. In a chemical change, a new substance is formed. So you have a different substance, you have different stuff at the end of a chemical change than you started with. So the atoms and the molecules, they change, they rearrange. Those chemical bonds I talked about earlier change around. They make new bonds, they release bonds, and so you end up with a new substance. Chemical changes are never easily reversible. So we talked about our physical change of water freezing into ice. Our chemical change, if we have hydrogen peroxide, something we worked with last year during floating CHADS, we can see it is made up of 2 oxygen atoms and 2 hydrogen atoms bonded together. So this is hydrogen peroxide, H2O2. If you leave it sit long enough, it changes. So it's a chemical change. Those atoms rearrange, those bonds change, and you end up with 2 waters and an oxygen. So it's different substances at the end than at the beginning. Here are 3 examples of chemical changes where we have different substances at the end than at the beginning. None of these are easily reversible. A nail rusting, a bomb exploding, or Alka-Seltzer fizzing in water. So how can you tell? How do you know if a chemical change has taken place? There are a few signs to look out for. The first one is the formation of bubbles. So in a chemical change, sometimes bubbles of gas appear when a reaction is taking place. So if you have a change in matter and bubbles are somehow appearing seemingly out of nowhere, that's a good indication that a chemical change has taken place. The second sign to look out for is something called a precipitate forms. So a precipitate is when 2 liquids are mixed and a solid forms from the reaction between the 2 liquids. So we're going to watch a quick video to see an example of this. Got a drop of clear liquid being dropped into another clear liquid. Exciting, we see a yellow solid. So if we let that settle down and filtered it out, we would see that that is a fine yellow powder. That is a yellow solid that's being formed. And that solid is called a precipitate. Another sign of a chemical change is a temperature change. So it takes energy to rearrange bonds. We saw all of those pictures of atoms moving around and bonding to different things and releasing bonds. So if there's a temperature change, that's a good sign that a chemical change has taken place. This could be energy being released, so it actually gets hotter, or energy absorbed if it gets colder. So if you've ever used one of those ice packs where all you do is kind of crack it and 2 things mix together and suddenly it's really, really cold, that's a chemical change happening in there, and it's absorbing energy, which is causing the temperature to decrease. Another example of a chemical change is a color change. This one can be tricky because there are some physical changes that seem like the color changes, so be careful with this one, but a good indication that a chemical change has taken place is if there is a change in color. Another sign that a chemical change has taken place is if light or other energy is emitted or absorbed. So a glow stick is a great example of this. If you've ever taken a glow stick, cracked it in half, 2 liquids will mix, and suddenly light is being emitted from that glow stick, that is a chemical change taking place. And finally, if there is a change in smell, so before and after the change, the smell is completely different, that's another good example of how to know when a chemical change has taken place. And that's it. Please let me know if you have questions. Go back and look at your lab and see if you can tell if chemical or physical changes have taken place. See ya.